In this video, we're going to look at covalent bonding. So a covalent bond is a shared pair of electrons between non-metal atoms. Atoms of nonmetals form covalent bonds to fill their outer shells. So we're going to look at drawing dot and cross diagrams for covalent molecules. The first example we're going to look at is hydrogen. So if we draw one hydrogen atom, it has one electron in its outer shell. So it needs one more electron to fill its outer shell and be stable. So here's another hydrogen atom. What these can do is share their electrons to fill their outer shells. So I'm going to draw a dot and cross diagram to represent this. So to draw this, we want to overlap their outer shells, and we want to draw the shared pair of electrons in the space where the two shells overlap. Next, I'm going to show you their displayed formula. This is a different way of drawing the covalent bond in hydrogen. We show the covalent bond with a single line. So this single line is one covalent bond. And lastly, the molecular formula of the hydrogen molecule will be H2, because two hydrogen atoms form one molecule. The next example we're going to look at is oxygen. Now, oxygen has an atomic number of 16, which means it has 16 protons, and because it's neutral, it has the same number of electrons. So one oxygen atom has 16 electrons. I'm going to draw the electron configuration of an oxygen atom now. So as you can see, oxygen has 2 electrons in its inner shell, 8 electrons in its second shell, and 6 electrons in its outer valence shell. Now it has 2 electrons that it needs to gain in order to have a full outer shell. So oxygen, similar to hydrogen, can share electrons with another oxygen atom to form covalent bonds. Now I'm only going to draw the outer shell in the dot and cross diagram. Now once again, we want to show their outer shells overlapping. And don't forget to draw the electrons that are not taking part in the covalent bonding. And then we want to draw the electrons that are forming covalent bonds in the space where the two shells overlap. So as you can see, each oxygen atom now has 8 electrons in its outer shell by forming 2 covalent bonds. Now the reason why this is 2 covalent bonds is because between the 2 oxygen atoms we have 2 shared pairs of electrons. So the displayed formula would look something like this. And you can see the 2 lines show the 2 covalent bonds. And the molecular formula would look something like this. O2, because there's 2 oxygen atoms in one molecule of oxygen. The next example we're going to look at is hydrogen chloride. I'm going to draw the electron configurations of hydrogen and chlorine now. Hydrogen needs to gain 1 electron to have a full outer shell, and chlorine also needs to gain 1 electron to have a full outer shell. So they can share these electrons to form 1 covalent bond. So the dot and cross diagram will look something like this. And it's important to note here that I've only drawn the outer shell for the chlorine atom. The displayed formula would look something like this, showing one covalent bond, and the molecular formula would look something like this. Because in one molecule of hydrogen chloride, there's one atom of hydrogen and one atom of chlorine. The last example we're going to look at is carbon dioxide, CO2. So I'm going to draw the electron configurations of carbon and oxygen now. Now, as you can see from the molecular formula, there are two oxygen atoms in a molecule of carbon dioxide, so we need another oxygen atom. Now, when these form covalent bonds, they're going to form a dot and cross diagram that looks something like this. Carbon forms 4 covalent bonds, 2 with each oxygen atom. So the displayed formula would look something like this. And the molecular formula would look something like this. Now I want you to pause the video here and try to draw the dot and cross diagrams for the following covalent molecules: fluorine, methane, nitrogen, water, and ammonia. I've provided you with the molecular formula as a guide. So this is what you should have. It's important to note that I've only drawn the outer shells of the atoms. The displayed formula for each of these molecules would look like this: a single covalent bond between 2 atoms of fluorine, 4 covalent bonds in methane, 3 covalent bonds between 2 atoms of nitrogen, 2 covalent bonds in water, and 3 covalent bonds in ammonia.